Today we're going to learn to factor a special kind of polynomial called a quadratic. A quadratic is just a polynomial whose degree, the highest exponent, is 2. And we're going to do that using a method that some people call the AC method. So this type of polynomial called a quadratic, it has to be in standard form before we can work with it. Standard form for a quadratic is ax squared plus bx plus c, where a, b, and c are just numbers. Not only that, but if you like the visual of the box to organize your work, you're going to be able to use it again with one extra step in the beginning. So first, we have to make sure that we have a trinomial, so 3 terms. Then we have to make sure it's in standard form, which is always descending order, meaning listed out from the highest exponent term first down to the constant. A and B are called coefficients because they're in front of or multiplied by a variable, an x squared and an x in this case. C is called a constant because it is not multiplied by a variable. Let's talk about how we're going to do this. So you already know from factoring that you're going to use this box and we fill in the first term in the first box and the last term in the last box. But now we have a problem. We have a plus 11x and we don't know what to do with it. We have 2 boxes. I have to have something in every box. So what I'm going to want to do is split this middle term into 2 pieces, but you can't just do it randomly. There's a method. So let's look at what A, B, and C each are. Remember that if there's not a coefficient in front of a variable, we can assume that it's a 1, and it might help you to draw it in. So in this case, A is 1, B is 11, and C is 24. Now, I want you to multiply A times C. 1 times 24, that's 24, right? And I already know that B is 11. So what I'm looking for is 2 numbers that multiply to 24, but those same 2 numbers have to add to 11. All right, that can be a little tricky. It takes some trial and error. We're looking for 2 numbers that multiply to 24 and add up to 11. So here's what I do. I think of all the numbers that could multiply to 24, and I list them out like I did right here. 1 times 24 is 24, 2 times 12 is 24, 6 times 4, and 3 times 8. Now I look at those pairs of numbers and I say to myself, is there any way that they could combine? They could add up to 11. Well, certainly this one cannot, the first one, right? So that won't work. 2 and 12, I can't get 11 out of that. 6 and 4, that would be 10, no good. But 8 and 3, they do add to 11. And so those are my magic numbers, 3 and 8. Here's what you do with them. We're splitting that 11x into a 3x and an 8x. And it doesn't matter which place we put them, okay? We can do this because 3x plus 8x is 11x, but we picked them carefully. We started with the fact that they had to multiply to give me 24, A times C. So now that I know those, and they're both positive, I'm going to write them in here with the positives, and now all my boxes are full. GCF, every row and column, just the same way that you've done it before. GCF, the first row is x, and the second row is positive 3. GCF, the first column is x, and the second column is positive 8. Look what I've got. There are my factors. I factored my original problem, and I have x plus 3 quantity, x plus 8. Remember, you can always check your work by using the arrows or looking back at your box and making sure that what's outside the box multiplies to give you back what's inside the boxes. Okay, not everyone likes the box method, and that's still fine. You can do the same thing that you did before if you prefer it. Remember, you want to multiply A times C. 6 times negative 10 is negative 60. And I need two numbers that multiply to that, multiply, but add to negative 11. All right, multiply to negative 60, add to negative 11. So remember what we do. We focus on the negative 60 first. Let's forget about negatives for a second and just think of numbers that multiply to 60 in general. All right, so 10 times 6 comes to mind quickly. 2 times 30, 3 times 20, and 4 times 15. We forget a lot about that one. All right. Now, before I worry about the negatives, if they're going to multiply to a negative, I know that one of the pair of numbers is going to be negative, not both, because two negatives multiplied make a positive. All right. And I also know that they're going to have to add up to a negative number. So the larger of the two numbers is going to have to be negative. Let's just think about in general. Is there anything I could do to add or subtract these numbers that would give me 11? There isn't. And 2 and 30, is there any way to combine those numbers, positives or negatives, that would give me 11? No. Same with 3 and 20, it won't work. But 4 and 15, if I subtracted, I could get 11 out of that. Now I have to be careful. I can only make one of these negative. Which one, when I added them together, would give me a negative 11? It's the 15. If that's negative, negative 15 plus 4 is negative 11. So you have to play with it. You can use Desmos to play with the numbers and figure it out. But make sure you pick which one is going to be negative carefully. All right, that gives me a way to split the middle. And so I have a positive 4x and a negative 15x. Now if you bring down, we split those. If we bring down the first term and the last term, don't lose that negative in front of the 10. Now we have two pieces here, right? Two groups. And if we group them together and look for the GCF, of those separately, look for the GCF of those. So GCF here is 2x. 2x times what will get me back to 6x squared? I need a 3 to get the 6, and I need another x to get x squared. 2x times what will give me positive 4x? I need a positive 2, and I don't need another x. I already have one. GCF over here. Remember to take the sign of your first term I can see that a negative 5 is my GCF. Negative 5 times 3 will give me negative 15, and I also need an x to get this back. Now here, negative times a positive will make it negative 10. So I need positive 2. Negative 5 times positive 2 is negative 10. Look at what happened. I have a GCF that's an entire expression. It goes in front, and what's left goes in the other set of parentheses. Now, you guys, you could have done this in the box. I don't want you to get overwhelmed. You don't have to do it this way unless you like it. I call this the pants method because if you look, this is a belt buckle. The legs are kind of short, but here's a leg, there's a leg, and then we have some feet over here. All right, if you were to do the box, this works exactly the same way. You use the magic numbers to split the middle. First term, first box. Last term, last box. Your split was positive 4x and negative 15x. And you do your factoring, your GCF, and it comes out exactly the same. We have a 3x and a positive 2. We have a 2x and a negative 5. And you can see that my factors come out the same way. I want you to try this one on your own. You can use either method. Pause the video, come back when you're ready to check your work. Okay, how did you do? Did you split the middle correctly with a 2x and a 3x? Keep in mind that everything in this problem, in the given expression, is positive, so you don't ever have to deal with negatives if everything is positive. Okay? It'll never come up if it's all positive to begin with. Either method, you got the same answer. Remember that if you had the 2x plus 3 first and the x plus 1 second, that is absolutely just as correct. Okay, I know I've told you, I don't like to trick you, so I'm warning you about those kind of tricky things that might come up. The first is that it might not be given to you in standard form. So you need to put it in standard form. Okay? Rearrange it. Make sure you carry the sign in front of a number with it. The second is sometimes it's not a trinomial. If it's not a trinomial, I'm going to show you some special case tricks later, but for now, make it a trinomial. What's missing is the x term, right? So if you rewrite it with a 0x, remember 0 times x is 0. So we're not changing the value of this problem, this expression. So it's a valid thing to just put a 0 in where the term that's missing is. The other thing that could happen is that it can't be factored. And this is an example of one that can't be factored. You just need to try it. And if it doesn't work, that means it's prime. You can see that this is going to take some practice, and I'll give you plenty of it. Remember that factoring a quadratic expression always comes down to GCF. We do it over and over and over again. So you have to get good at it if you're not already. Next, don't be fooled by the tricks. They will happen, absolutely. So I want you to look out for them. When the instructions are factor and it's quadratic, your goal is always 4 terms so that you can use the box or pants and the magic numbers to help get you there. It's not really magic, it's math.